Okay, so let's solve this question. The question states that consider the following sequence of operations on an empty stack. So on an empty stack, this set of operations are performed. Look closely right over here. The S variable is defined by means of this pop operation and stores the value that the pop returns in the inside of this S. That is important because this S is used afterwards. Now look over here. Consider the following sequence of operations on an empty queue. So this is the set of operations that are performed on an empty queue. Now look closely at over here. This dq is returning a value that is stored inside of this queue. This is important because of this statement. The value that they seek from us, the question is seeking from us a numerical value. This is a NAT type question, numerical answer type question, and over here S plus Q is the answer that they want from us. So it's a pretty straightforward question. If you know the concept of stack and queue, you can very easily solve it and get the marks. I'm going to do it so that you have a very good demonstration. That's all. So a stack is a data structure that follows the LIFO principle, right? Last in, first out. So if the input is made from the same place as the output is made from, right? So if this is the input, then this is the input, and this is the input, and this is the input. So this is the last input, and that last input is going to be the first output. That is what LIFO implies. That is what your stack implies. Now over here, this is the stack, and this is the set of operations that are performed on that stack. So this is push 54. So 54 is going to be pushed inside of this. After that, 52 is going to be pushed inside of this. After that, a pop operation happens. So this is going to go out, right? So let's just take it out, and then after that, the push operation of 55 and then push operation of 62. So 55, after that there is 62, after that there is another pop. So this 62 is going to be popped out and stored inside of this S, implying that the value of S is equals to 62. Very good. Now come over here, the Q, right? The queue, the empty queue that has been provided to us, we have to consider it. Inside of the queue, the data structure follows a principle of FIFO, that is first in, first out. So if data is being inserted from this point, and it is a linear kind of representation for the concept of queue, so the data output is going to happen from the other side. So this is going to be the first element, and that first element is popped out first, and that is how a queue operates. Very good. Now let's see. 21 is NQ'd. NQ means insertion, DQ means basically retrieval. Okay, so 21 is NQ'd, so 21 is basically NQ'd over here. After that, 24 is NQ'd, so 24 is NQ'd over here. After that, a DQ happens. So this 24 has to be not this 24. The output happens from this place, the input happens from this place. That is how the Q operates, right? So a DQ over here is going to be removing this 21 from it. Okay, so let's just remove this 21 from it. This 21 has been removed. Now what? Now NQ of 28, so 28 is going to be NQ'd. Now see, because we don't have space over here, we need some space for it to work with, right? So in 28, after that 32 is NQ'd over here. Okay, then a DQ happens. So this 24 is going to be DQ'd inside of this Q. So Q becomes 24. That is going to be answer for Q. Now let's see. S has been found out by us to be equal to 62. So 62 is going to be added to what? It is going to be added to 24. So let's add 24. And what does this gives us? The answer that this gives us is 8 plus 2. What am I even doing? 2 plus 4 is equals to 6. And 6 plus 2 is giving us 8. So 86 is going to be our answer, and it is a very simple question, and I do hope that you can solve this in the examination, and this demonstration helped you with that, and I will see you in the next video. Thank you.